So the overarching topic is how a mathematician comes to what I'm going to call a ticket, which is a proof that the axioms of ZFC entail through an explicit definition what I'm going to call the scaffold axioms or the observation axioms that correspond to observations. And this is then given as a proof of the authenticity of the existence relative to ZFC of the um, observed objects. Okay. And what we say then is we what we have then is a relative existence account of the observed objects. We say that if a set exists, then this object exists. If a set exists according to the axioms of ZFC set theory, then this object exists. These objects exist according to the axioms of the observations, the observation axioms. So we're not saying that the ZFC axioms are true. We are not saying that the observation axioms are true. We are saying that what is true is that the ZFC axioms imply the observation axioms, and all we're doing is we're using the inference rules of first-order logic. That is what mathematics then relies on. So we're saying that the hardware of mathematics is the inference rules, and the operating system software is the ZFC axioms, and the application software is the observation axioms. And just as we can have the same application, the very same application, the thinking is, that can interchange data and interface with the user on two different operating systems. We could do the same thing with the observation axioms. So the thinking here is that, maybe if we had different set theory axioms, then we could substitute those different axioms for the ZFC axioms. And this would all sort of exist very, very, in this sort of very remote and arcane location that in a sense would somehow be independent of the intuition of the application. So we're saying, just as this is sort of the tablecloth under the tower of wine glasses approach. We can yank with skill. We can yank very quickly the tablecloth while keeping the wine glasses stable. Okay. We can do this very quickly. Just in the same way, we can do the same thing with the axioms of set theory. We can replace the ZFC axioms with some other axioms while retaining the intuition characteristics of the observation axioms. So we may have to change the application source code, but the users of the application still have the same experience, and they can still transfer files. Maybe they have to convert from one format to another, but they can still get their work done. It's still the same application, two different operating systems. So this is the account of the mathematical intuition and it's an account of what a mathematician does to convince himself that observations are worth studying, and that they correspond to uh, something of mathematical interest as opposed to, say, economic or philosophical. And the claim now is that what mathematicians do in part is they make sure that what they're studying exists by creating these, I guess, what you would call relative consistency proofs, that the consistency of the ZFC axioms imply the consistency of the observation axioms. That's the starting point. And then the issue becomes, how do we organize these sort of, walks, or these trails that start from kind of the base camp of ZFC and enter the wilderness or the semi-wilderness of the observations and the observation axioms, you know, and then how do we use this base camp of ZFC? What's the proper way to use it? What's the proper way to make sure that the axioms of ZFC don't contaminate our intuition process? And how do we do this? Well, we arrive at these sorts of, like plateaus or something, or these vistas, these places where we don't look back at the base camp. We look out to the landscape, the view, this beautiful view, and we take in the scenery, and we take in the experience, the subtlety, and this is what fills our senses. The question here is sort of, how do you use the ZFC axioms? And I think, it's just like, X Windows. How do you use X Windows? It's just a new way to use a computer, it's different from just the terminal. It's sort of, what else can you say? It's a different way to use a computer. It's sort of like, it's a program that doesn't do anything, or doesn't do anything obvious. You have to come up with this sort of new model of the way the computer works in order to understand the role of this program.